Oh, that was for Thursday, Friday. So we've got. Do you remember the names of the parts of these diagrams? These are parallel lines and a.
What is it?
What's this line called? Good, a transverse. Okay, so we've got a transversal going across two parallel lines, and there were things that we knew, which is about the angle, right? So we know some angles are the same, some angles do what? Supplementary add up to 180. What's the other one? Complementary add up to 90. We're going to learn a bit more today, which is, right, we've got this diagram here. You know what they're called, which is vertically opposite. So let's, because we can stick this in after. So these are vertically opposite angles. What do you know about vertically opposite angles, by the way? They're the same. Simple as that. Yeah. So this angle and this angle are the same angle. Right? Now, the next two, what do you know about this angle and this angle? Well, I was going to say, what do I know about them? They are the same. These ones are actually called corresponding. Also known as F angles. Why do you think they're called F angles?
They make an F.
They look like they make an F, yeah. Any idea why they're called corresponding? You know what the word corresponding means? But
It's like
I wouldn't say necessarily are. What do you think? Ron?
like that.
Yeah, okay, we go with that. What do you think? Yeah, Colton, Ken? Yeah, what's the word corresponding mean? Yeah, things that correspond basically have a link, and I would say the reason why these are corresponding angles, because if you imagine, all right, I often do it like this. Like if I cover over, if I do this, if I cover over this half of the diagram, okay, we've got an angle like that, yeah. If I now move that out of the way, right, this angle here is basically just the same thing as that, yeah? So it's like you took this diagram and just did it again. And this angle and this angle are basically the same angle in different versions of the same diagram. That makes sense? So if I split this diagram in half down the middle, okay, you've basically got that bit there and this bit here. They're the same. So I would say they correspond to each other because they're in the same place but in a different version of the diagram. Does that make sense? Does that work for you? These ones are called Z angles. If you like. Z angles, Z angles. You put the little angle signs. Yeah, I did put them in there. And they are called alternate. I say just alternate, but you can see alternate interior, alternate angles. There's basically two words, meanings for the word alternate. Anyone know what alternate means? Okay. So you go from one side to the other, yeah? Alternating current, have you seen that in physics? Electricity goes from one to the other to the other to the other, and keep alternating. Yeah.
one thing to another. Place to another.
Well, I would say corresponding though is one place to another, but I would say alternate here, alternating, because we go from one side of the transversal to the other side of the transversal. Okay? And they're interior because we're inside the light. Okay? So there are other F angles and alternate angles and things like that in these diagrams. We've just kept them simple. I hope that works for you, Fallon, that drawing of a cat rather than parallel lines. Okay, so let's have a look at our diagram here. There's going to be a lot to write. So, can you describe that diagram for me? What do I have, Riley? Say what you see. Angles and what are the important points to this diagram? Parallel lines, how many sets? 2 sets of parallel lines. So we have parallel lines here, we have another set of parallel lines here. It's important that they are parallel. Okay. Say it again. Okay, so we'll go through that in a bit. I was just going through what do we see to start with, and the first thing we see is that we have parallel lines. So we have one set of parallel lines here and here, and the transversals themselves are also parallel lines. So I've got a transversal there, and I've got a transversal, and the transversals are parallel. Okay, very common diagram. So first of all, let's go through all the vertically opposite angles. Now, Kate's already said there are 8 of them. So, which ones are vertically opposite? I'll start with 1 and 4, 2 and 3. Okay? 5 and 8. You carry on. 6 and 7, 9 and 10 and 13 and 15 and, okay. So vertically opposite are quite simple. So let's have a look now at some corresponding angles. Now, I'm going to do this with some highlighters. What's the letter that we recognise corresponding ones with? F's. Okay, so I'm going to draw myself an F. I see that line and I'm going to go down and I'm going to do that. Okay, so that would identify which ones as being corresponding.
14.
The obvious ones I was thinking, I'm thinking of which ones are in the F, but 4 and 16. Now, I'm not saying you're wrong, Bebe, because, but I'm just looking at the obvious ones to start with, and then we can explain why you're right. There is another F, which is over here. Here's another F. So the ones we were looking at are 8 and 12. How does that sound to you? All right. Now, Ben suggested that 2 and 14 are also F angles. What do you think?
They are.
Yeah? Now, just so you're aware, that's perfectly good because the F doesn't have to be the right way up. I can draw an F upside down. So have 2 and 14. No. So 4 and 16. And then we've got 2 and 40. And then we've got the same. Now, also, this is where we get complicated because there are also F's that are backwards. So here, so the other ones are 3 and 15 and
Every.
1 and 30. Not only that, but F's can also be, as long as there's parallel lines, on their side. So I can do that one down like that way. So now I've got 6 and 2. Now, you might start realizing that in a diagram like this, there's going to be a lot of corresponding angles, right? And it's probably not the best method to try and highlight all the actions. So we just kind of go, well, the ones that are in the same places, they're going to be corresponding to them. So how many do you come up with? You work them out, write them down, see how many you come up with. Let's see if we get an agreement. Okay, let's move on then to the questions. And what we're going to do, guys, is look and say, right, remember we're calculating angles, we're not measuring any angle. Nothing is to scale. So what we're going to do is we're going to use all the knowledge we have about the different types of angles. So what do we have? We have vertically opposite. Next one. Complementary. Supplementary. So corresponding and alternate, right? We have all of those reasons for making statements about how we know angles. Now here's my biggest tip for this particular thing. Don't feel you have to go in order. Sometimes you might want to work out angles that are not even asked for, but it will help you work out the ones that you're asked for. So would anyone like to talk me through any of the angles in the first diagram? This one? With reasons. Colton.
Can I go up there?
If you like.
So we're talking about here. We know this is 90 degrees because there's a square.
Yeah, that's at 90.
That must mean this is also 90 degrees.
Because?
Because 1, 2, 3 opposite.
Okay.
And just because these are two straight lines and they're not intersecting, this is also this angle with the 50 is also this is gonna be 90 degrees. So
If you what?
so the 50 here.
Oh, okay. We can work that out as.
So 40, that's gonna be 40.
So this whole thing should be 90. So that we know that's 40 degrees. Okay.
And then with that, then we know this side must be 90. Right. So.
Well, now I would say from this point on, these are just like I can hear Jameson saying these ones are vertically opposite. So now I would have can anyone get to that 40 quicker than having to work out each? Jameson?
I just don't like doing it.
Yeah, no, you can do it however you want to, but there is I would say, quicker way for this, which is?
Pretty sure it's like 50 plus 90, which is 140.
Yeah.
140
Because
Pardon?
these angles are all on a straight line, so they're called
What?
angles on a straight line.
Uh,
Supplementary. So we've got 50, 90 is 140. That makes that 40. Okay? So a couple of ways to do it. Anyone want to tell me one of the other ones? People. Hey. But ask you to be more concentrated, yeah? Not the doodling. Stay on target. What do we think? Is there any other reasoning? Come on, guys. You all wanted to move on from the previous diagram, saying you've got it all. Braden. We've got P and R left. Okay. Okay, good. So we've got parallel lines. We've got a transversal. So 50 and P are, what's the name? Corresponding. So we know that P is 50. Go on then, Phoebe. You know R is. Okay, so we know this is 50. What about this R? Anyone? Yeah, James. Oh, okay. 50, 90 is 140. Angles in a triangle. Let me just draw that. It wasn't the way I was expecting it to happen, but we do have a triangle. Angles in a triangle, which is the next thing, add up to 180, which means this must be 40. Therefore, this one is 40 as well. There is another way to get that without having to do the triangle.
Wait, it's like it's just
We can't say just use your eye. We've got to have a reason.
no, like
Yeah, but like I say, without having to use that triangle, there is another way to get to that point.
so there's a very simple line after we solve P right here. That's 50. This is also 90 right here because we already established this is
Yeah.
vertically
So
opposite. So
this is, yeah. We know that was 40. We already had that.
this is also like up here. It's hard to explain, but it's like
Okay, yeah, I get your idea.
it's 90. It's like
So are you saying that this here is 40 and
Yeah.
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 There is another way. Go on, Colton.
So you can use supplementary angles. You know this line, there's these two angles, which we know this is 40.
Yeah, but let me say, if I know that's 40 already, I can just say that I don't need
Yeah,
to do
yeah.
any
Well,
more.
I guess.
What I was saying is, like, without even working out that that was 40 in there, without doing this triangle, I could work out this is 40. Anyone got it? Brains?
this. Yeah. There's a right here.
Exactly, yeah. Here, look, is another. Here, down there, and down there. So R and Q are the same. Yeah, it is as he said, those are F angles as well. So we could have done it that way. Now, what you've just seen is, to solve those angles, there are multiple different ways of doing it. Which one's the right way? None of them. They're all equally valid.
There's some that are faster.
All I'm aware of is some of you have definitely been fully on this and you were thinking, and some of you were zoned out. Not written stuff down, you've not thought about it, you were not interacting, and you know who you are. Okay? But you can see the process we went through, right? Thinking it step by step. And yes, you can work out lots of angles that are not necessary, but it's not a problem if it gets you to the right answer. It might not be the most efficient way of getting there, but as long as it's correct. Okay, so this is a common diagram. I'm going to let you finish off both of these for yourself, work out those angles. So, what I always do with these diagrams is, first off, for me, I identify where the parallel lines are. So my parallel lines are here. I've got that line and that line. Guys, gents. So with parallel lines, I'm then looking for a transversal. I'm trying to separate this diagram. So I can see that here, colour, here is one transversal. So that's making me think that 30 is going to be alternate to S, which means S equals 30 degrees. Okay. So I should, maybe if I can't remember, alternate angles. Now, using that same method, how do I find T? Gents, how'd you work out? Using that same method, how can I work out T? Go back. Okay, so first of all, he's identified this is the transversal. So the angles that I'm interested in are this one is the same as T. Yeah? So I've just got to figure out this one, and you're saying that that one is... Oh,
160 degrees, so obviously it's 160 plus 120, 180.
not 120,
Oh yeah.
just 20. Yeah. 160 plus 20 makes the 180 because it's on a straight line. Yeah. So T is the, again, the Z angle, but backwards. So we know that T equals 20. So again, they're alternate. But these ones up here were supplementary. Okay. How do you feel about that?
Mr. Potts, the thing on a
Oh yeah.
Oh, it's fun. Much fun. It's fun.
it's not fun.
It's trigonometry. What do you want? There's trigonometry.
It took me like an hour and a half.
Okay.
It's too.
Can we have some different voices? Talk me through any of these ones. You're the same voice. You're the voices I want to. Brennan, what would you offer us to start with? They're not corresponding. They're vertically opposite. Yeah.
Looks like 115.
All right. We're going to avoid the looks like. It is a one-way, but how can I know that X is 150? Okay. So first of all, like I've said, identify the parallel lines. So here are the parallel lines. The transversal that Brennan is talking about quite correctly is this line down here. So we can see that our F angle, 115, which makes X 115 degrees. And he's already said that W is vertically opposite, so W is also 115. Okay? That's all right, we're all on it now together. I just thought you must know it because you were looking away, so you must be like. Did you write down what we've already done? No, you didn't do that either. Come on, guys, I've got the same few people. Anna, go for it. Okay. Oh, okay, there's one way. Do you want to see what she's doing here? So angles in a quadrilateral, that's 4 sides, all add up to 360. So I'm not saying this is how I would do it, but it's not a problem. 32 plus 115 plus 65 is, that's 1. Then 180 plus 32 is 212, is that right? So then we've got to do 360 minus the 212 is 148. Now, does Y look like a 148?
Yes.
which means Z is, or Z is, those two add up to 180, so Z is, now can you spot a quicker way of getting that than instead, right? Yeah. Well, it's not corresponding, but it's a Z, which is a alternate angle, yes. But you get it. So we could have actually gone straight to writing Z is 32 and done the same, but the other way around. But what Anna did was perfectly good, the logic she used. This is a good way of showing you there's lots of possible ways to get to answers in this topic. Okay. Some people are not impressive. Some people, this is a tricky, it's not tricky, but it involves critical thinking. The thing that we practice when we do our problems. Okay? So those of you that are keen and do your problems of the week all the time, you're going to be much better at this kind of thing. On that note, I will draw your attention this week to problems of the week. And I will suggest you go and have a look at problem B.
Oh, that's this. I remember I looked at it.
Have a look.